Mhm. Just waiting for the audio to start working, and we seem good to go. All right. So, welcome back to the stream on the Blaze engine development. We continue on from where we finished the texture loading system, like not even system, just loading a texture and showing it on the screen. To now, we're going to actually add some game entities in the system. So we can have different entities with their own meshes, with their own textures being separated instead of being all in bulk inside the miscellaneous data as we have it right now. In a sense, it is refactoring. In other senses, it is sort of re-engineering the particular problem, right? So let's dive right into it. First things first, we're not going to make like a complicated system. We don't need a big object oriented hierarchy. We don't need ECS. Not right now, at least. We can later decide what problem we are trying to solve in order to specifically refine for that. But right now, the only problem I'm trying to solve is that each entity has to be its own thing that should contain its own data. And welcome back, Silvera. So, side-based programming language, that's nice. Can be an interesting thing to make programming languages. We will eventually actually integrate a scripting language in here. My yesterday night, I was searching about using Lua versus using Scheme or Lisp. I'm very partial to Lisp because personally, I find it to be a much more elegant language. Anyway, coming back to today's topic, the whole idea is to refactor the entities out, and the whole goal is just to decouple entities from the MISC data and actually couple everything related to entities together. So first thing, some things are like simple gimmies, which is transform is an easy part of an entity. So we can just say entity here, and we can say that it will have a transform. So it has a transform. Okay. Then you can say that an entity also has a mesh. Mesh. We don't have a mesh here, so let's make one. And you might ask, what is a mesh? This whole thing that we did with vertex buffers is a mesh. Okay, this is sort of not really simplification, but actually overcomplication of what a mesh is, but we leave it as it is for now. Okay. Continuing on, once the mesh is separated out, what other things does an entity have? In order to render, it needs the position, rotation, etc., the location, so that's transform. It needs the vertices, so that's mesh. And finally, it needs the textures and colors, which is the material. Now, normally materials can also contain shaders, etc., but for now, we will only contain the texture. So material, all right. And we grab the material from, so these things, those are all camera related. So we just have to grab this and place that into material. Okay. Now, one thing to be careful about, the sampler here can be reused. We don't necessarily need separate samplers for each material, but temporarily we'll say to do reuse for the sake of simplicity right now. All right. And now another thing that happens is this model transform doesn't need to exist anymore. Cool. So miscellaneous data is now cleared out of all those things. So this has been separated. On the flip side, we need to add them back as entities themselves. So another little thing I will do is I'll separate the init into create miscellaneous data. And sorry, not create miscellaneous data, but sorry, not create miscellaneous data, but actually have a separate system, because we need something to manage entities and they need to be able to allocate the entity themselves. So I'm going to call it entity manager. Some ECS stuff calls it world, etc., etc. But I'm just going to call it something simple like entity manager. It will have entities. So entities, and it will have the count of the entities. Size. Or actually make it more descriptive, count. I've said it's a size T, but it can just be UN32T because I doubt we'll have more than 4 billion entities anyway. So we leave it to UN32. The only thing is this will still consume 64 bytes because of the padding. So we have extra space that we can put in. And we will probably need it because we need capacity. The number of entities is not the same as the number of entities we will have created and allocated, right? Okay. Now, transform, mesh, and material are all by value in here. They could just as well be by pointers, and we can allocate them separately on their own, like their own arrays, let's say. But for now, we're gonna keep it simple. We'll keep it as transform, mesh, and material. But I will make them private. That way, when we actually move to having them as, so one of my conventions is to add the member M in front of it if it's private. So when we move eventually to using pointers, we wouldn't have to refactor all the code. So we'll do a transform and we call it transform. So that's a getter. Okay. Returns em transform, nothing else. Now I actually can shorten this myself. So I will do that. Getters and setters, only do getters. Finish. No, what am I missing? Transform is already done. Mesh and material. There we go. All right. So I just use a resharper to generate all of these for me. So that is an entity. It's automatically here. All of these needs to be initialized. So again, we need a separate constructor now because this is private. Entity, which takes transform, takes mesh, and it takes materials. So material. And again, almost a trivial constructor where we just assign things. Right? That's that. I think this can be constant. Same with this. Same with this. And we should be good to go with that. Okay. Now, these are all plain old data. That is deliberate. By keeping this as plain old data, we can just copy them without any issues. This vertices here is no longer necessary because that's a very temporary thing. All of it will be written to a vertex buffer as soon as it's created. So moving on, failed because everything is depending on the MISC data specifics like that. Okay. First, it says 9125. There is padding because of alignment specifier. I'm not wrong. The padding need should not be there anymore. So, okay. Now, model transform is not a part of the MISC data, which is fair. It's actually a part of entity manager. All right. So here again, for entity manager, I will create a little accessor called get span. This should return a STD span of entity. Actually, I don't even need to do that. I can just write a begin and end. So entity pointer begin entity pointer, and that's an iterator. Entity pointer is automatically an iterator. Does nothing but return the base entities pointer, and this does nothing but return entities dot entities plus count. Nothing to it, right? When we make const, make it const. No discard, no discard. All right. So that's entity manager. Almost trivial. That is deliberate as well. Okay. Because we want to keep things simpler until we know what our needs are. Now, since entity has been separated, list data in it will not be correct anymore because Michelin's data in it actually contains. 1 second. So Michelin's data in it actually contains all the vertex creation. So first, I can say auto vertex buffer size equals vertices times vertex size. Vertices don't exist anymore because they've not been allocated. So, plenty of issues now. So instead, what we'll do is we'll allocate the entity manager separately. So I'll move this entity manager and this entity, take it out. I'm sorry, 1 second. We need to also take transform and mesh. So we take all of that out. None of that is used here anymore. Add class. Class name is entity manager. It should automatically have its .h and .cpp files. We'll ensure to add that and include DirectX math. Also include CSTD root for the standard input values. And we'll include void for the welcome. Similarly, VMA. You have to be careful, VMA comes after void, no matter what happens. So we keep spaces between them. Okay, and with that, we have the entity as a entity manager as a separate class. Again, create entity manager. So entity manager pointer create, that's entity manager create. What should it take? So first, it will take a global memory. Just a forward declaration is enough. Then, then second, it will take how many entities do we need? So you int 32T count or capacity really. That's all we need for entity management. Can get definition. It out there. Um, Good. So what all does an entity manager contain? That's the constructor build. Entity manager consists of the entity pointer, so data, and it consists of capacity, so you want variable capacity. Needs nothing else. So I'll write it in line and we can move it outside later. Entities, which is nothing but data. Capacity, which is literally capacity, and count, which is 0. Because when we start, we don't have anything allocated. We can const that, and that's fine, right? That's good to go. What's next? So once that is done, entity manager create will automatically have its definitions more or less set up for itself. First thing we'll do is we'll allocate the memory for that. So mem allocate entity size of entity. Uh, a line of entity. I should make a macro that simplifies all of this. Probably do that again without showing it. So capacity has been allocated. Once it's allocated, entity pointer is required to store it. So entity pointer data equals this. It's going to be byte pointer here, but we will just reinterpret cast it. That should be fine. Similarly, entity capacity already exists. So we can directly create an allocation. So that is entity manager pointer or std byte pointer alloc equals lem allocate size of entity manager a line of entity manager. Once the allocation is done, return new alloc entity manager, which takes a data and capacity. Okay, so again, entities are all automatically constructed. Entity manager will take a certain amount of capacity, right? Certain amount of data available to it. And that's it. Next thing we need is each entity needs to be created on top of this entity manager, which is a separate step. So again, entity pointer, create entity. Now, what does an entity contain? It contains a transform, a mesh, and a material. What does a transform mean? A transform means position, rotation, and scale. So that would be a transform information. What I can just do here is ask for each of these. So directx xm float 3 position. Okay. Similarly, directx xm vector rotation, directx, that will just be float scale. And this will actually become quite long. So it's easier to just take a transform here, right? Transform. This can be a constant reference. And we can construct transform separately. Mesh, on the other hand, we will create ourselves. All it needs is a vertex buffer, allocation, and buffer size. All of this we can create ourselves. What we need is data. So we need vertex data. Vertex needs to be added. We have to copy that as well from here. Again, a lot of this will probably change as we simplify things over time. Since vertex data is taken, you also need size. These are both guaranteed requirements. So I'll ask for a span directly. Okay. Which gives us a pair of vertex and the size of it. Vertices. Then once vertices are loaded, the rest I can do myself. So all of this can be automatically easily created. Texture. Again, allocation, view, and sampler can be done if we have texture. For texture, we just need the data for the texture. So MD span. I don't know if MD span is even a thing here. So for MD span, I think it's C++23. We don't have MD span available. We can take texture data as a separate struct. So, or we can take texture as an image, as a first car star texture file. Again, as I said, this will be changed soon enough. Right now, we just want to get things from where they are to where they should be, and then we can patch the things to, you know, change how the data is ingested. So now, again, going back to missdata.cpp, we have all of that creation code that is invalid now. So things we have to do. First, these remain the same. We are not changing the shader right now. Size of vertex is no longer valid here. So pipeline itself has to change based on, the entity itself. What I will do is make vertex something common and necessary. This is more or less temporary. And later on, we can say that no vertex can be separate. But for now, let's just consume the activity manager dot h here, which is for some reason not showing up. Build solution. I think it might show up after that. Okay. Really is not showing up. I'm certain it will soon start working. Coming back. Entity manager. Save this. Build. Really doesn't seem to be happy with it. Okay. So again, entity with entity, it takes the transform. So transform goes in. Second is mesh. We don't have a mesh, so we have to create one. So it will take a mesh. And finally, it takes a texture file. So texture file has to be converted into material. This will be returned when it is allocated at a particular location, which is rotate as M entities, entities count, and count will be incremented by 1 so that after this we move to the next one. So entities count should be entity. It is exactly an entity, not an entity pointer. So what we can do is we can just copy this over. All right, another issue here. So each of these contains data that is pure data, which means each entity needs to be destroyed at the end of its existence. So we'll add destroy here, void destroy, which needs to be definitely called at the end of an entity's, cycle. Also, this depends on render device. So this will have to take render device forward declaration device render device, right? Because vertex buffer to destroy the buffers and the images, we need the render device to exist. And we can generate a definition for destroy as well. That's an entity destroy. But more likely it should be, so we did a create entity, and we should have a destroy entity similarly. Void destroy entity, and it shouldn't need to take anything. Instead, entity manager itself will keep a render device pointer so that it doesn't have to manually handle each so manually require render device from the outside every time. It can just use the render device that is available. And this can be a reference. Not a constant one, but it can be a reference. The render device, and that will be found. But perhaps pointer itself. Anyhow. So with that, we should be able to continue on with this. This entity should take an entity. Alright. Entity manager itself needs to be destroyed, but there's not much to do except to call destroy on every single entity inside it. So void destroy, uh, generate definition, go back, generate definition. Okay. We will add to do here. So this won't compile until we're done. We could create a structure. Then we the definition so not entities. Okay. Okay, that should be it. All right. Now, entity manager. All of the overloads take 2 items. Yes, because on the device, then the device is not provided to us. Allow will provide another estimate. Okay. What next? Once entity manager create is done, this gives us an entity manager. This entity manager needs to be destroyed, so that is here. This destruction will involve doing a take. The first it will involve for each. So print UL32 T I equals 0, I less than the total count or relay capacity plus I. Then we do a destroy on each of them. So entities relay entity pointer, the iter equals entities. And we can simplify this again by writing the whole pointer math directly. Entity pointer end equals entities plus capacity. That's one beyond the end. Iter not equals end plus iter. Okay. And here all we need to do is iter destroy. Oops, yeah, it's destroy entity iter. So each entity will automatically be destroyed and ensure that that happens. And once that has happened, we will take entities, or more like set it to null pointer. We will set capacity to 0. We will set count to 0. And this assert will ensure that whenever this goes out of scope, it is doing exactly that. That's destroy for entity manager. Since we haven't constructed it, we haven't put the destroy anywhere yet. So we don't have to bother with it at this very moment. But moving on, miscellaneous data.cpp as a vertex. Okay, it seems to have worked. So it is asking for dot slash entity manager touch. Why is it doing that? I think I can understand it. Entity manager was created in the wrong place. Okay. The move should be a bit more careful with the creation process because the folder is incorrect now, as you can see. Add existing item, entity manager.cpp. Now it should work, right? All right. So we have vertex pipeline should be creatable now directly. So what changes is the vertex buffer creation because this is now a part of the mesh. Well, not all of it, but some of it is a part of the mesh. So since we have delineated each section, it becomes much easier for us to copy paste it. So now entity manager. This is why I've been delineating things so far, right? The whole reason why each of these gets braced and commented is because I can just pick it up and move it. This wouldn't be. So vertices that were here, that data is no longer important to us. So that shouldn't have much of an issue anymore, really. Oh yeah, array is not a part of includes. Okay, now it's able to handle this. Of course, we don't want that. Move it there. And this whole thing itself moves away. Yep. I need to pick the comment as well. This whole thing moves away. And we will move it somewhere into Blaze or app state probably. So when we create the app state here, well, this will probably be in Blaze. So during the Blaze app init here, we create the app state. So inside app state, we will also start. Okay, one by one. First, we need a place to paste this. So I'll paste it here and include entity manager. It will get included automatically over time. And here I'll add a Google comment. And I'll put a warning saying, okay. So that's a warning directive. It will actually not compile thanks to the warning. So invalid. The processor command. Interesting. But basically, currently I've set up things such that warnings are the same as errors. But still, I don't know why that happened. Anyway, vertex buffer size. So that is mesh.vertex buffer size equals vertices. So we tried to do this, but it's no longer necessary because one of the nice things with span is it has a size bytes option directly. So we take the size bytes. Again, here it's mesh.vertex buffer size. That will do the buffer create info, etc. for us automatically. Create entity means render device, which will be p-render device. And again, something that should be able to handle itself. Vertex buffer. That's mesh.vertex buffer. Mesh.vertex buffer annotation. Shouldn't have any issues, so what's wrong with it? Use SDL log error because VK check depends on log errors. Okay, what else is missing? So I don't want this kind of a dependency. I don't like it. So instead in macro utils where I am actually depending on SDL log error, That's where the dependency goes in. So if this header is a part of my code, through whatever reason, SDL log is automatically added. If that is ever removed, SDL log will be automatically removed. Always have to be in control of where these things come from, because we don't have a automatic module management system. Actually, we do now, but we're not using it. So anyway, here we are. So this is mesh creation. So all of this together, again, size bytes, sorry. All of this together automatically handles loading the mesh into this mesh that moves into the entity, and they're all good. Material has to be done next. So what do we need for material? Well, what's wrong with this? Not all control paths return a value. WinGW 32-bit binaries, why are you using WinGW? It depends on that. But no, I do not know how to get that. I've never used WinGW myself. I directly use MSVC, or if I need the G++ compiler, I use Linux. If you're learning development, I do suggest using Linux over Windows. Makes life a little easier, or the start at least. Check it out. Anyway, return. So again, entities plus count. All right. Material is still left. We haven't done material yet. So let's look at material creation. Again, this is about a list data. Texture right here. Copy that whole thing. So with this array, texture the same. That is fair. So hold on. There should be a simpler way of doing this. So this is the texture one. It can't be reduced in size. No, why? Still. Okay. Anyway. Or as I like to say, we trace it down all the way to the end here. Cut that. That's the texture part. Again, move it to the entity manager CPP. And after material, we paste it with font. I'll switch to 120. I did get some comments saying the font was too small to follow on a mobile screen. And since most of the people these days use mobile screens, suppose this is a better thing to do. All right, it needs STP. This doesn't need STP anymore. So STP image can be moved away into entity manager.cpp for now. This is a temporary thing. Mesh pipeline. Right. This is no longer really valid because entity failures are just a return null pointer from here. STP failure will not lead to requirement of deletion of vertex buffers, for example. Actually, it will. It won't need pipeline destruction anymore, but it will still need a vertex buffer destruction. So GP allocator and vertex buffer becomes mesh.vertex buffer. And then whatever allocations again, mesh dot. Right? So now category error, failure reason. Okay, this is fine. Extra loading is occurring there. Then the device to when the device texture is material dot texture. Texture allocation is material dot texture allocation. That's one way of doing things. I think I'm going to flip the problem on its head. So I'm not going to set up the textures like that. Instead, and same for the p-render device really. we'll leave that in there. So up here, what I'll do is instead of material, I'll ask for a texture. So we can image texture, we can image view, texture view, we can sampler, right? And the material just gets moved all the way down after the end of this whole scope. As you can see, there's a lot of code there. So right here, which is equal to, and we can now just place the texture, view, and sampler. We also need texture allocation. So texture allocation, which we'll place right where the texture is. No, I guess that by mistake. Definition is not found. Here, texture allocation. So the MA allocation. So that does it for the creation of this particular material. Again, all of this can actually be moved in there, and the material can be moved up here, and material equals assignment can be moved inside. Okay, now this device is nothing but render device. Okay, hold on. We'll come to that in a sec. We'll just set up the render device first. So up here, since we'll be using this quite a bit, render device equals star p render device. And we can assert here that p render device exists, right? Similarly, can assert, no, we don't need to assert anything else. So that will automatically handle all the render device references. This becomes render device dot device. Render device dot device. All of this will be cleaned up eventually. This will all be abstracted away. But for now, we will leave it as simple stuff. Frame is incomplete. Definition has to be included. Done. Device. Again, render device dot device. Right? Okay. So now texture has been uploaded. We just copy pasted all of it, and texture has been uploaded to the material. At this point, both the entities material and mesh are well formed. The transform is not yet done because though that's just directly taken as an input. So that means an entity has been completely created. So what does an entity destroy do? First, it takes an entity and asserts if the entity exists. Then if entity dot, and what I will check is init. This doesn't exist, so we will create a member function, which is a Boolean indeed. Okay. And it just returns the state of mesh dot vertex buffer and material dot texture. If both of these exist, then it is init. You can even call it or, really, because either both of them are there or both of them are not there. As we've seen, if texture creation fails, we uninitialize the mesh. This can be made const. Const it is. Should probably ask for no discard, so we'll do that too. And we will move all of this. Oops. We'll move all of this to, never mind, for now. We'll refactor it later. So anyway, entity of the default constructor has nothing else. No warnings so far, so we're okay with that. Go back, not that is a if, and we'll do a not here. So if not is in it, we'll return, right? If it's not in it, then we don't have to do anything. So we just skip this. And that way, since all entities will be zero at the start when it's initialized, all of this will automatically be, so all destroy entities will automatically be false. We do need to make sure that happens. So one of the things we do need to do is here inside allocate, we need to not malloc when set destination is entity. So I think it's called data. Val is 0 and size is capacity times size of entity. So we just set it all to 0, right? Once it's all set to 0, we don't have to bother with things anymore. Okay. More troubles, more things to question. First, it asks for this rotation system. We're not going to particularly change all of this. What we'll only do is we'll take the entity system and get everybody's transform and then modify everybody's transform. What we will instead look at is the bind vertex buffer. So here we don't have one vertex buffer anymore. Each of these have a separate vertex buffer. Each of these have separate textures. Not good right now. Not good considering both of these are actually the same texture and the same vertex buffer, but we would be loading it twice. But it is what we get at the moment. We will fix it, of course. But as I said, step by step, incremental changes, right? Okay, entity manager. So destroy and create. We haven't created it yet. So inside app state, create. We will create the entity manager. So after, actually first inside app state itself, we need to say entity manager, do a forward declaration, pointer, and oh, keep pressing the wrong buttons. Entity manager. Okay. Similarly, after this, it should consume an entity manager pointer. That's app state. Generate definition. Well, in reality, I'll just do that. We'll get entity manager. Cool. So that's app state creation. And by doing this immediately, we will have an error here because we haven't initialized entity manager yet. This is before miscellaneous data, so we'll do it before miscellaneous data. Entity manager pointer, entity manager equals entity manager create memory and capacity, which is how many elements, how many entities do we think we will need? Let's say 10. It's a very small number. Definitely not the right thing. Definitely not the right value for the final thing, but for now we're fine. This was a bug. I need to fix it because render device can return null. I don't think it does. As far as I know, it never returns null, but it can return null. Again, this as well, entity, not entity manager or not entity manager is in it. And as you can see, I'm sort of phasing out is in it because I think you shouldn't need to check it. If we get something, then it's valid. If we don't get something, then it's not. That should be the end all be all of this particular system. Entity manager. SDL log error. SDL category location. entity manager failed to init. Perfectly fine. Return a null pointer. Also fine. The window created, destroyed here. We need to copy this down here as well. And we also need to destroy the render device. So render device, destroy. We know it's not null because we've fixed that here. Okay, what next? This has to be fixed. It's not in it. We return null pointer. We also need to delete everything else. SDL log error. SDL log category application. Data failed to let render device destroy entity manager destroy. It should be first actually. SDL destroy window. Done. Cool. Small corrections. It's called the scout method. Leave a place in a better way than you found. Boy Scout method. It's called scouts now. So here, instead of doing MISC, we can do entity manager. So it's now part of app state. So app state dot entity manager. There's a begin and end. So hold on, what? Can it actually do that? That doesn't seem right. So entity manager has we did do begin and end, but let's not keep it like this. And instead add an iterator structure. So struct variable and have a begin and end for that. And this will only contain, in fact, the entity pointer begin and entity pointer end. Private, public, and begin, and then it needs initializers, so those will be. Do we automatically get like benefits of being inner classes? I forgot how inner classes worked in C++. Entity pointer and begin, and using 32T count. So we're assuming entities are not removed, so they will still be iterated through at the moment. Not good, not good at all, but again, we'll get to it. So I will just log in down here. This destroy entity to do actually make here make entities return ID, make it a sparse index system. Okay. What does that mean? Some other time. Begin and end. Begin, nothing but begin. And end is begin plus count. Because this is const. That's it. Structure gets that. And we can give an iterable return, calling it return iterable entities, count. then there is indeed inaccessible. There's a protected go through, it is still inaccessible. So then public it is. Variable solution. Here there is fine, it will be like const. Can do that. Okay, next. Go back to global. To global. App state or entity manager. Header. Now it's a bit better because it shouldn't be transform at all. It should be an entity. It takes an entity. And here it should be entity dot transform dot rotation. Similarly, this will again be entity dot transform dot rotation. Okay. Going down here, this again has to be done. So mesh pipeline, we've said that this is going to be constant, so that we won't change. We will instead wrap all of this until the draw call. Okay. And we make a for each. So for entity const, and it just has to be const now. So entity app state, entity manager, iter. Okay, there is a thing. I think what we've done is we've said that we shouldn't need to say entity manager every time. We shouldn't need to use a pointer. It takes it by reference. And that you can do wherever this is. Yes. So entity manager, entity manager, entity manager. All right. Okay. Build. Yeah. Errors. Question insert vertex buffer doesn't exist anymore. It's entity dot mesh. Oh. Entity doesn't have const returns anymore. This should be. We're not using C++ 23. Too bad. Otherwise, there is a thing known as deducing this that we could have used for transform. But anyway, so this is the non-const version. We want the const version. Because that's not valid because we're not returning a const reference, right? Each of these needs a const alternative to mesh, const, and const. Const expression will not be correct. So this is it. Similarly, this one, it's actually material. So material, const ampersand, or like material, const, and it should return material. Okay. Good. Still failing. All right. So entity dot mesh dot vertex buffer, that is fine. Model transform is no longer for each because there's only one local transform from the current system. If we will take it out here, so transformed and local transform equals then const equals entity dot transform. Again, the system should be able to optimize this out. Vertices dot size becomes entity dot mesh dot, this should be vertex count, which doesn't exist. So we create a member function called vertex count because that's not right. So instead we do size t vertex. It's size t here. It should be UN32. So we switch it to UN32. because that's the maximum Vulkan can handle. So might as well restrict our mesh to that. Of course, this will incur a padding. And so what we can do is we can also say that vertex buffer size can be limited to your because more than 4 gigabytes is a lot for a single buffer, single mesh. All right. And that actually compresses that data automatically. But certain things will again have to change. First of all, this vertex count is a value now. That's done. Second should be if your idea should be a problem, what it should get errors because what it buffer size is size type. This will be a static test. You want WD. Done. The solution model transform is unidentified. This is setup. We will move it to the place where we said we're going to do setup for things. That was inside Blaze's own init at the top. So here we have vertices. We will also really transform init up there. But we will integrate this. We will add the transform code here. All right. Because app state has been created, we can now set up the entities from this place. So this will actually be entity create. And we can get to it. So vertices are already there, in place. Make these positions and scale stuff has to change. What I'll do is I'll not set it up, like just comment all of this out. We will do the add thing first. So what is it that we're doing? So app state was created here. It was assigned to this app state thing, but we didn't get app state out of this. So app state pointer app. Actually, you can take a reference. State equals. This will be a bit weird. Equals app state pointer. This requires a static cast to app state pointer, right? So this app state, oh, sorry, it's a small one, is a void pointer. So you remove this, it becomes a single point. So it's a void pointer. This becomes a single pointer that gets cast to app state pointer, which is then dereferenced to an app state reference. So now we say app state dot entity manager dot create entity. It takes a transform. So now we take this transform, move it down here. We will say this is a transform model transform. And really, I don't even need that, right? Station. Again, that's equal to this. The identity takes a model transform, takes vertices, which are available from there. The span will automatically take care of construction. And texture file, which is wall.jpg. It's not actually wall.jpg anymore, if I'm right. Because it was hard-coded. Okay, need to be careful with this. So in entity manager, yeah, we've hard-coded the file here. Don't want that. So this will be texture file. There we go. So we loaded that. All good. Come back up. Texture file is here. So that will be wall.jpg. It will actually be changed to assets textures wall.jpg. I have changed the paths on the project itself internally. So it needs to have these changes also modeled in. Now, model transform does this, which is fine. Here, what I'll do is I'll say model transform dot position dot x equals minus 1.0 f. we edit it so that the second model transform is set to the negative location. Okay, let's try building. Let's see if there are any errors. There are. Sampler is unidentified in descriptor image info. Okay, another thing to be careful about. We will need one descriptor per object now. So this also, even though this is a part of the miscellaneous data, and it can stay that way, it will have to be moved out eventually. But I'm not going to do this, as in you can manage descriptor sets to do it properly, but I'm not going to do this deliberately because I will not be using descriptor sets for my work. So I'm just going to bypass the entire problem by simply not dealing with this thing. So number of textures, let's say 3 textures, so we can have up to 3 entities. So maybe 100 textures and 100 combined image samplers. So we can have, let's say, 100 entities. Okay, I am joking. It should be one uniform buffer because the camera of 3, let's say. But image sample, let's have 100, right? So we can have 100 different textures. Now, when we do render device.get num frames, that's the max number of sets. Actually, that should be 100. Let's say maximum number of sets you can have is 101. We can leave some for the uniform buffers. And what we will also do is we'll change the descriptor set layouts. So here, we've said that there are 2 bindings to one descriptor set. And so we create a single descriptor set layout with 2 bindings. This means that each of these has to be updated at the same rate. But the uniform buffer is per frame. The combined image sample is per material. So these are separate update rates and they will have to be written separately. So yeah, that happens. Uniform, which is not uniform, it's actually per frame descriptor set and binding. This is, and that goes away, per material descriptor binding. Okay. Now descriptor set layout binding is 1. Second, p bindings equals ampersand per frame descriptor set binding. So that creates single descriptor set layout. Okay. We go back there, descriptor set layout, and we make it an array of 2. Why an array of 2? Because we have 2 descriptor sets now. In fact, std array of 2. Alright, so descriptor set layout doesn't work anymore. We will have to take descriptor set layout 0 specifically. Then I remove the const from this. I do add const on that. In fact, those can be const expressions. Those they never change. We explore across runs. And descriptor set layout info has taken that one. Now descriptor set layout and create info dot bindings equals ampersand per material descriptor binding. Okay. So frame descriptor. Okay. So now we set it specifically to per material. And we do it again with material set layout set to 1. All right. Build. Yeah, that's erroring. That's doing a lot of errors because set layout here cannot work. So this becomes 0. Since 0 was done after, so this will have to be done in reverse order. Texture allocation, buffer allocation, sampler, and texture views don't exist here anymore. So those have to be removed. And they have to necessarily be moved inside entity. Did I forget to do that here? So destroy entity. And I did. I did, in fact, forget to do that here. So we don't have a device. So what I can do is I can say render device. So first, assertive entity even exists. Then we can take a render device and render actually VMA allocator. Allocator equals P render device, GP allocator, recreate device, device, and device again, right? Cool. So sampler is a part of entity material dot sampler, entity material dot texture view, entity material dot texture, and similarly entity material dot texture allocation. Entity mesh vertex buffer, and finally entity mesh vertex buffer allocation. So this will take care of deletion of things when those be const. So we'll do that. Destroy entity is here. Says it can be made const as well. Doesn't sound right to do const on that. Internally, it does work on changing entity, which is a part of the array. Anyway, mission instance data was padded due to alignment specifier at this position. Okay, but how many was it padded at? Descriptor layout dot data. I set layout count because descriptor set layout. Count size. Static cost, of course. And descriptor set allocate info. Okay, we have one set that we're allocating here, which is the per frame set. So we'll just allocate that one. Okay. And the second one that we have to do. So this descriptor image info, that will be done within the material. So, hey, that's a pain. We don't have a way of getting the material to. We don't have a way of getting this to the material. Right? We don't have a way of getting the descriptor pool to the material right now. So we cannot correctly create descriptor sets for the materials. You need to hack that in. So that can be done by taking this out first. So here we descriptor set left is the uniform buffer descriptor set. Move that there, and we cut that out. So that will write. That is fine. What we need to do, we need to allocate the descriptor set and use it from the entity. So this is a hack. It's most definitely a hack. But when you create this, you will need to give it a descriptor pool. So we create descriptor pool. That's a hack. Okay. So I'm going to write that here. hack. Okay. Do remove the descriptor pool dependency. All right. So we move on from here. There should be marked no discard, so no discard it is. There Huzzah! A lot of new problems have been created. So going back down to create entity, remove that. I think it's causing issues. Well, create entity. That's pretty long, eh? Nope. We create a script to build. So we'll get the pool and we'll allocate the script set. I'll write this texture to it. So where is that texture now? Texture creation, submission, buffer end material has been created. This material will also have the descriptor set. So entity manager H, material, and we'll add descriptor set here. So we create descriptor set, descriptor set. Okay. And that means constructor will require descriptor set as well. So material constructor here, okay, takes a pre-constructed material, comes from create entity. No, comes from create entity. That was where we were, so that's fine. Okay, that is okay. We create descriptor set. Descriptor set. That works out. Now descriptor set write, descriptor set image info. So write descriptor set have been created. So they are what I call primed. But we don't have a descriptor set yet. So that needs to be created, which we do with vk allocate descriptor sets. Takes device, which is nothing but render device top device. Allocate info, which is nothing but descriptor set allocate info. And the descriptor sets, which is nothing but this descriptor set. And what else? VK check. VK check. Okay, so there's that. We move the descriptor set allocate info, so we take descriptor set allocate info, const descriptor set allocate info. VK structure type descriptor set allocate info. P next is null pointer, descriptor pool is pool. Descriptor set count is 1 and layout is, so we don't have the layout. Lovely, isn't it? We actually need to ask it for the layout as well. So not just descriptor pool, but we create descriptor set layout. This should have a way, yeah, change signature to match this definition. What happened? Texture file, it does not take that. Okay, descriptor set. All right. Now, one of the things here is all of this, right, is a lot in a single function. And so we will create like a create info struct that will automatically take this in later on, because this is not going to be long time. So let's look at create entity. What's your problem? Did I make a mistake somewhere? But anyway, set layout. So descriptor. Yeah. So now it can take a layout. It will then allocate this descriptor to write to that descriptor. This needs to have a call. So vk write descriptor set. So vk update descriptor sets device. So that's a render device dot device. Write count is 1. Write is the right descriptor set. Copy count is 0 and null pointer. And that generates this. So this is fine now. Okay. What next? We are leeching descriptor set here. So, leeching descriptor set. That is fine. This data was padded. How much was it padded? There is an issue. So because I said let all warnings be errors, it started actually causing issues because it doesn't give me all the information anymore. Earlier, it would say we have padded it and that the padding takes a certain amount. Okay, this has failed again. Create entity because it has to take the descriptor set. So that's risk data. This app state, risk data, descriptor set layout. So that's good. Set layout. There was per frame descriptor set layout. That's set layout 1. App state dot miss data. Descriptor pool. Okay. Set layout 1 cannot be converted to a descriptor set. So that is the issue. We asked for a descriptor set instead of a layout. Cool. That worked out. And this exact same details are a part of the second one. So both of these will handle themselves. They will initialize their own media build. Okay, so far so good. The only thing is unresolved external symbol entity manager create. So entity manager create is right here. Takes 3 parameters. Entity manager dot h takes 2 parameters. And that's where it changes. What changes? It needs a render device. So this needs a render device pointer holder device. Build. One failed. Why? It does not take 2 arguments because it does take the render device as a pointer. Build. Succeeded. Run it. Okay. An issue has been created. Field with -13. I don't know what -13 is because Vulkan configurator doesn't exist. All right. Oops. Run it again. It is okay. We can see it here. Side nothing to us. Right. It really is not saying anything. So it failed with -13. VK result -13. -13 is error unknown. Wow. Like just wow. Create graphics pipeline is now failing with errors unknown. We've mostly not changed anything here. The only thing I can think of that has been changed is the script set layout that we were just looking at. So the script set layout create info. Layout has been created. Then we changed the binding to material bindings and we created the script set layout. They are two separate descriptor sets, right? 0 and 1. Here, let's assume there is some issue with the driver copying the data incorrectly, and it means two separate structures. So, third name descriptor set layout character info. Sorry, this one is per frame, and this one is per material. Build solution. Yes, so and run. Still an error here. Minus 13 again. All right. We can check using a debugger what's happening. So the script set layout has size 2, takes one of it, and it should assign from there, which it has done, ideally. This one has combined with sampler 1. Pipeline, so per material binding, per frame descriptor binding number 0, binding number 1. Okay, this is wrong. It has to be binding number 0 because it's a different set now. Okay, let's see if this was the issue. Nope, that was not the issue, or that was not the only issue. Disable code checks. Why? Did I click something by mistake? Maybe. We can do information. See what's up with that. Okay, failed to device prop. I don't care about that. Error we can create pipeline. That's here. So now what? The shader itself can have an issue because the shader doesn't match up. Bindings in the shader don't match up. But that is something that Vulkan configurator should normally tell us. So let's look at that. Let's skip the best practices right now. That's cool. Let's try it again. Big amount of details. There. I'll remove the layers part. Information and layers are both unnecessary at the moment. Run. Okay. Here. So if the resource variable is declared initially, the corresponding descriptor set must match the shader stage. So that is in fact the shader problem. So what we did was we had said per frame data and texture was a part of the per frame data. However, now texture is not a part of per frame data. Instead, texture is, sort of by itself. Uniform sampler to the texture, it will automatically be assigned the right numbers. Interesting things that Slang is able to do. Try running it. Still an error. Okay, let's see. Set 0, binding 0, variable texture, but descriptor set layout binding stage flag was vertex bit. Texture is defined in vertex shader. Here, that's fragment bit right there. Binding is 0. Stage flag is fragment. These are both fine. Per frame descriptor set, is at 0 per material descriptive set, per material descriptive set is at 1. Okay. Pipeline layout by layout create info. So it takes these. Set to 0 and set to 1 have been should be correctly identified by the system. Okay. What I'll do now is I'll just say uniform straight buffer camera data. I'll just call it camera. We don't need the per frame data anymore because that was just to create a single set. And now it's both in globals. Rebuild. Run. Still an error. Descriptor set 0, binding 1, variable is texture, but was not declared in the pipeline layout. I see. So what is happening right now is a little weird. This per instance data, sorry, so camera data is only being used in vertex buffer, which means, and texture is only being used in the fragment buffer, which means each of these are being considered as a single stage. They're being considered in a single stage. So effectively it's something like that. And that. So it's behaving something like this. And this is perfectly fine, but the numbering will be a little different because both of these will be set 0 in two different shader states. So this is shader stage vertex. No, wait, these are shader stages themselves. The numbering scheme is an issue, and this seems like something we're getting directly from using slang. Like it's a result of using slang. So I'm going to do a little bit of a cheating. Move it back. Okay. I'll manually bind this thing. So vertex binding, VK binding, 0, 0, VK binding, 0, 1. This is binding location, comma set. So with that, since we have manually set it, should be okay. Oh, yeah, I did too far there. That should be it. Build, rebuild solution. Run it. Okay, validation errors, descriptor sets are not correctly set up. Descriptor sets are not correctly set up for this. So what's happening now? So when we look at the drawing board here, so iter here, we bind descriptor sets in graphics for the pipeline layout for one descriptor set, which is the miscellaneous descriptor set. So this is for the camera. What we don't have is the second one. So first set is 1, and this one comes from the material. So this is entity dot material dot descriptor set. Still some errors. What are the errors? Texture is being used in draw, but never updated using update descriptor sets or a similar call. Did we not? Entity manager CPP. Update descriptor sets is right here. So what went wrong? Right, descriptor set does a descriptor set here, image info is here, image info takes the sampler and texture view. Texture view is constructed in the same place, so it should be fine. That is the descriptor set. Combined image sampler, destination binding is 0. Set 1, binding 0, right? So we wrote it to the wrong binding. You see the kind of issues we can have in Vulkan when we don't look at it properly. Implicitly reset the command buffer, which is not set. Did we forget to reset command buffers at the start of the process? I think we probably did. So after we take the resource, the frame, we wait for fences, we reset the fences. We need to reset command buffers. We haven't done that. So reset frame. That should be I think that can be extracted as a function soon enough. We set command tool. We don't do per buffer, we do per tool directly. Frame in use dot command tool. And reset flags is 0. We do a VJ check to ensure that things are resetting correctly. And we can run it again. Okay. Wait for fences has failed. All right. So now what is happening? We wait for fences. Something's happening in our synchronization. We've waited for fences. Then we reset those fences. So fences are now in a reset state. Command tool is reset. We go through this entire process. Begin pipeline barriers. End pipeline barrier and command buffer. Submit. We wait for the fence. So we do not move ahead until this point. Okay. Now, once we release it, this whole process starts again for the next, what do you call it? Next transfer frame. The next transfer frame goes here. It again picks the same frame, 0. It waits for the fence. Once it is there, the fence has been set by, so the fence would have been set by the previous submit. It waits for it, resets the fence again, resets the command tool, starts using it, goes all the way down here, submits it, waits for that whole thing to finish, and we reach up again. Seems fine to me. Okay, where is this? Which one is this? Okay, so if this app iterate, which fence count is this? I'm guessing frame index 0. Yeah. So frame index 0 is not working properly anymore. I am waiting for fences here. So let's put a check here and run it again. So now we wait for fences, frame ready to reuse fence. We go through it. Buffer has been destroyed, descriptor set has been created. Continue. Again, second wait for fence. Goes out, goes forward, continues. And we're back there again. Frame ready to reuse. Failed because of timeout. All right. What else can we try? So we can try using the frame, actually increasing the frame here. So we can take a render device dot frame index All right. And at the end of this process, we can increase the frame index. So down here, uh, here, we can increase the frame index. So render device dot frame index is equal to render device dot frame index plus one modulo render device dot get long frames. Okay, the solution. Run. Doesn't seem to be working. Alright, which frame index? Frame index 2 has now suffocated itself. So does reiterate for fences, reset the frame. Roll, timeout, block until the condition is satisfied. Timeout is 0, then the frame doesn't wait, simply returns. In this case, the condition is not satisfied, even when no actual wait is performed. This is fine. Hmm. If the condition is satisfied before the timeout is expired, reiterate for fences, returns VK success. Otherwise, VK returns timeout. It has returned timeout to us from here. That was a little bug. So it worked with 1 and it doesn't work with 2. Let's actually go to the app state and we will not create the second associative base itself. We will not create the second one. See if that changes anything. So if we do not create the second entity, does that change how it performs? No, it's still stuck. So it's clearly not an issue of the second entity having a different value or anything. Okay. What else? What else can be the issue? We create a new descriptor pool. The descriptor pool is a part of the app state. The previous 2 frames have not used. Okay, we can try something else. So we can try just not having any entities whatsoever. We'll figure it out if the problem is loading or not. So it is entity loading. And loading an entity is causing the issue. All right. So what has changed here that will cause such an issue for us? Possible issue. We are doing something with fences here. Let's check frame. One frame. Nothing else. Okay. We don't need that frame here anymore. Build, rebuild. Okay. That has stopped itself again. Wait for fences on frame index 2. All right. What else can we try? So after we create both the entities, we can try just doing a VK device idle. So all the fences should have released if we do that. Once in Blaze, after init, when everything is set up, here we can do VK device idle. This is bad, like unquestionably bad, but it's something you can use for debugging. So that we can wait for fences. So all the device has idle. Although the device has idle, the fences have not released. Okay, let's look at this. Or alternatively, what we can do is we can just say, hold on, there's wait for fence reset or false. Okay, so they have not reset it. We have to manually reset it. Are we manually resetting it here? Wait for reset. Sorry, wait for fences. Reset fences right there. Reset command pool. This is done after acquire next image. Have forgotten this, but resize swap shell if recall. Okay. Interesting. I don't even know what tools to use to check fences really. Current frame, not frame ready to use. And I'm doing it for frame number 2. But frame number 2 should not have been used at all. So likely what is happening is one of these renders is the one getting stuck. Frame number 2 is the first frame that is actually used. So this is getting stuck. All right, so what are we missing? Pipeline layout, descriptor first set is 1, material.descriptor set. Vertex buffer is bound, offset is 0, binding count is 1, source binding is 0. Only one pipeline. Command draw. And push constant world transform. Something somewhere is missing. I just don't see it. Why? I don't see why. Let's print more stuff. There we go. Physical device buffer address features. None of this is relevant to us. Failed with -4. VTQ submit has failed with -4. -4 is device lost. The run was a bit too slow, I guess. GPU assisted validation turns off. Okay. Top, wait again. Nothing here. Wait for fences has blocked on the first fence that we threw at it. So there are 2 more fences after this, which are going to run. Okay. Keep it consistent across all of them. So the problem is somewhere in this. Entity manager dot iter is iterating over something that's wrong, let's say. So we come here to go in. It constructs an iterable for us. Go in, gives you a begin, which is, let's suppose it's a valid one. Let's check. It's the value of this entity. You can't see it. The position is a valid position. Rotation, I can't see. Okay, I do see it. Not that I understand it. Scale is 1. So this seems like a valid entity. Offset 0. Command buffer bind. Bind descriptor set. First set is 0. Descriptor set count is 1. So binds that descriptor set. This one has to bind material descriptor set. Okay, what was the value of my descriptor set here? We do not know. So entity material descriptor set. Is that a valid descriptor set? Did we or did we not set up vertex count? So while I do check vertex count like this in the mesh, did we actually set it up? So when we create the mesh in an entity, create entity with entity manager CPP, vertex buffer size. I don't think we ever set up the vertex count, even though it was created. So it's vertices.size. Static cost, of course, as everything is. Rebuild solution. Just giving arbitrary numbers into the build function, into the draw function. It should obviously not work. There we go. Acquire next image has been updated. That is expected because we do not handle window resizing or window closing and stuff. Cool. So these are completely separate entities, completely separately managed. We just create one more and it will also just work. A bot has been called. Huzzah. I can guess why. Certainly some annotations were not free before destruction of this thing. Okay. Which annotations? So obviously entities were not deleted. Why were they not deleted? Because inside inside app state, inside destroy here, we have not destroyed the entity manager is destroyed. Oh no, wait. So this is not the destruction function at all. Destroy. So render device wait idle, miscellaneous data is destroyed, and now entity manager has to be destroyed. So the fact that we hadn't done that was an issue. So taking the render device from this is not a big deal. In fact, the destructors that we've made won't ever be called. These are pointers. Okay, so that seems to be working. Now, just to test the fact that this will just work if we extend the number of extend the number of entities, I will copy the whole thing. Not even copy, actually. I'll just take a for loop int u8 32t int r equals 0 or make it pi equals -3 I less than equal to 3 plus plus I plus equals 2. So we'll step by 2 because otherwise we will be in a little bit of a trouble with the intersections between them. Though I suppose it shouldn't matter, so we can do it plus plus. We'll just take as it is and we'll set x. So model transform dot position dot x equals I dot cast to a float. And we can build. Hold on. There we go. Of course, the orders of their drawing look a little weird because they're always drawn from the left to right. So everything that's in the right is considered ahead of the thing in the left, which looks very trippy, you know. We can sort of make it look all right by setting the z-axis as well. So, and the other way around. So this should be minus 0.5 times static vector. This should look okay, right? Not really, but it's not too bad. Okay, anyway, we won't keep that in. We'll just keep it like this. It's good for now. This is the current state. Entities have been created, new entities can just be added. It's absolutely inflexible. The material system is hard coded, it just takes a texture. The descriptor sets have to be passed in like this. None of that is very good, let's say, but it's a primitive start. Next step is to create a bindless system. It will be another stream, but I think I'll just add it within the same, like, I'll just start working on it today itself. But a new stream. So yeah, have good fun. Thanks for watching.